Hello everyone. I am the General Chair of the CMMR 2021. Okay, I have to rewrite my name from Japanese to English a little bit. Wait a little bit, a while. Okay, and we will have an opening session from now, and I will show you my slide. And I will share the screen. This one. Okay, can you see that? Welcome to CMMR 2021. I am the General Chair of the conference, Keiji Hirata. And I'm very glad to see you all. Thank you for your very long time patience. This is a moment we have been looking forward to, really. Then, this shows you the features of CMMR 2021. This is a virtual conference, you see. And the starting day is today, the November 15th. And the end of the conference, 19th of November. And you will be able to find the papers of contained in the proceedings on GitHub at present. And every useful information is available on the CMMR 2021 Slack. So you have to watch the Slack information distributed by the staffs every day, every time. And please miss it. And fourth point, the time zones of the technical presentations, the sessions. And it was the very tough things to design the comfortable timetables for the people all over the world. And we have to design the two, so as a result, we have two time zones, an AM in Japan and PM in Japan. And the AM session of Japan starts at 9 to 12, the 3 hours session. And the PM sessions start at 16 to ends at 19 in JST, Japan Standard Time, and which are corresponding to the 19 to 22 of East Standard Time of United States. The another evening during the dinner time, and the 16 to 19 of JST corresponds to the 7 to 10 of UTC, the European time. This is the optimal design of the session schedule up to now, we think. The inversely thinking of that, the Japan morning 9 a.m. Corresponds to the midnight 24 of UTC, and the JST 16 to 19 session corresponds to the midnight 2 to 5 time session of East Standard Time. And usually usually thinking, we recommend to the European people listen to the AM session and the PM session, and the United States people please listen to the AM session, but it depends on you. Some of you may prefer the inverse time zones. It's up to you. The conference theme of the CMMR is music in the AI era. And as you probably know, the music informatics is the interdisciplinary collaborative research domain, and which has already been conducted with the various related fields, such as linguistics, brain science, the psychology, sociology, art and pedagogy, and so on. Recently, the rapid development of AI technology is changing not only the nature of the interdisciplinary collaborative research, but also the meaning of music for people and society. So CMMR 2021 aims to share knowledge with participants who share a common background, knowledge, and experiences in music informatics through in-depth discussions on the current status to vitalize interdisciplinary research and the use of AI technology. And this item, the non-author participants can attend the conference for free. This is a big advantage for many people. And as you see, as I do right now, the presentations will be made on Zoom, and the communication between staff, presenters, and audience, we will use the Slack. And during the conference and after the end of conference, you will be able to watch the presentation through YouTube Live and YouTube archives. And as before, this conference will make a post-conference proceedings as before, published by Springer. Then this slide showed you the percentage of presentation participants by country. In this slide, the presentation participants contains the paper author, students, and the music in total, and which are the people who have paid for the participation fee. And as you see, Japan occupies the many portion of the total participants, even though this conference is a virtual conference. Then next, so I showed you the percentages of non-author participants by country. Amazingly, more than half of the participants are Japanese from Japan. Although this conference is a virtual conference. It is probably because the several staffs or people of committee members intensively Selby. Okay, and so that is probably because the staff members have intensively invited many people around them, near to them, the colleagues and the students and the researchers and the friends to participate in this conference as a non-author participants. Okay, and we will have the three variable and very informative speeches and talks. the keynote speech is just followed by this opening session. Will be made by the Professor Shuji Hashimoto and Shuji Hashimoto. And the invited talk number 1 will be made the day after tomorrow, given by the Dr. Ketan Harjas. I'm sorry for my wrong pronunciation. And the second invited talk will be given by Professor Tadahiro Taniguchi on Thursday. Please look forward to them and enjoy it. Okay. The next slide. This is also important slides for us. The sponsors. We would like to thank you very much for generous and big support to hold the conference. YAMAHA, SIGMAS, Kayamori Foundation of Informational Science and Advancement, Tateishi Science and Technology Foundation. And YAMAHA is the YAMAHA that I think you know, the same company. SIGMAS is the domestic research group in Japan. And this group has been active for more than 30 years. And this is some subgroup of the more big Japanese domestic technical society for information and computers, IPSJ, which is somewhat counterpart to the ACM of USA. Kayamori and Tateishi is the private funding agency of Japan. Okay. The committee members are as follows. There are 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. I'm sorry. And it's me and Satoshi Tojo, Tetsuro Kitahara. Some of you may receive many emails and messages from him. And Shintaro Imai, he's engaged in the music part. And Masaki Matsubara, Masatoshi Hamanaka, Aiko Uemura, and the management chair is the formerly known as the local arrangement chairs. And they are very active to organize and the management of the technical aspect, mainly technical aspect of the conference. Hidefumi Obura, Ryo Hatano, Shun Sawada. And now Aoki, she is the secretary of the committee members at large. And let me say a little about the short and happy story named The Long and Winding Road to CMMR 2021, because to hold the conference is really, really very happy to me and to us, the committee members, and I think to you all. And as you see, the holding the conference was very difficult. So let me say a little happy ending story, a little bit. The story started at the October 2019, at the closing session of CMMR 2019 in Marseille. And I made the invitation announcement of CMMR 2020 in Tokyo. And the date was determined November 2nd to 6th. The venue was Morito Memorial Hall, which is, as which belongs to the Tokyo University of Science, and located at the very center of Tokyo, the very convenient to go and come to any places, from any places. And the concert hall is also near to the Morito Memorial Hall. And the theme was the same as the conference, music in the AI era. But unfortunately, in the early 2020, the COVID-19 disaster began to have an impact around the world. So, but we had the very little hope at that time, so that we made a call for papers and music of the CMMR2020 to the world in January 2020. And at that time, the deadline was set at April of 2020. But in April 2020, the COVID was very severe, rather than comparing to the early in the last year. So we have to reschedule the CMMR 2020 to this year, 2021. That was really a tough decision we made. We had many discussions among us and with the PRISM members. That was the steering committee in Marseille. We have many write and read the messages about that. At last, we have to decide to reschedule. And but ensuring the same program, hopefully in person, and at that time, and possibly remaining all committee members, including the reviewers and steering committee and local members. Then in this year, January, the conference date and the submission deadline was fixed at that time for CMMR 2021 anyway. And we were looking at the conditions of the corona disaster in the world, around the world, but the situation was not recovered at that time. So April of this year, also we had to make a tough decision to hold the CMMR 2021 as a virtual conference. We had at the time the alternative, including the postpone one more year. But that was the big gap since the 2019 to 2022. So we will hold the CMMR 2021 as the virtual conference as this. Those are the important dates, as you see. And the September 2021, the non-author registration started. And actually, at present, we have more than 220 non-author registration people. I think this is the world record of CMMR. I'm not sure if some of you know the correct data, please let me know. Okay. This is the last slide of my opening address. I used the poster for invitation announcement at CMMR 2019, the original poster. But this conference planned conference is missed. I'm very sorry. However, I'm very happy because like this, I can make an opening address of CMMR 2021. So this is the end of my address. Please enjoy the conference for 5, 4, 3, 5, 6, 7, 8, 9 for 5 days. Thanks so much. After the end of my address, the address from the scientific program chair, Tetsuro Kitahara, and the music program chair, Shintaro Imai. Please listen to these two opening address. Thanks so much. I'm stop the sharing. Professor Kitahara.
Hi. Okay. Okay. Good afternoon, everyone. Even though I don't know if it's afternoon for you. Actually, anyway, so from me, let me explain the basic model of the presentation we designed for this virtual conference. Okay. Okay, so first of all, so we show you the number of submissions and papers. Okay, so 48 papers have been submitted, and out of them, 34 submissions have been accepted. And this is the percentages of the country of the authors. Actually, so this this graph, according to this graph, the submission from Japan is the largest number, and so UK, Brazil, Canada, Germany, France, United States, and India, and so on. Okay. I'm sorry. Okay, so the basic policy for this virtual conference is to encourage both synchronous and asynchronous discussion, because synchronous discussion is the essential part of the conferences, we think. But at the same time, asynchronous discussion is also important because sessions. So some sessions may be located in midnight for some places. Okay, so so we designed some ways for encouraging both synchronous and asynchronous discussion. So, and each presenter presents their works on Zoom, and after that, so we have a Q&A time on Zoom. So similarly to on-site presentation conferences. Okay, and at the same time, so presentations on Zoom will be broadcast on YouTube Live. Okay, so these ones are synchronous part. Okay, and so the broadcasted presentations on YouTube Live is automatically archived on YouTube. So you can view presentation videos anytime on YouTube. So later, okay. So and then if after you watched YouTube video presentation, and then if you have some questions and comments, you can post them on Slack. Okay, so here is the asynchronous part. So so sessions are located on AM part and PM part on Japan Standard Time. So some sessions. So for some of you, some sessions are on midnight. But because there are some ways for checking video presentations asynchronously, so you can enjoy all of these presentations. So we have so there are some advantages of this model. First of all, presenters don't need to make presentation videos in advance. And then, so participants ask questions orally. At the same time, so participants can watch video presentation later, and participant can ask questions participant can ask questions in text later. And then participants can chat with each other on Slack. And so the new challenge is post-session discussion. So this is a opportunity for informal or personal questions and discussions. It may be also useful for greetings like name card exchange. So it will be organized with Zoom's breakout room function. Enjoy the sessions. This is the end of my talk. Thank you very much.
Okay, thank you, Professor Tetsuro Kitahara. Next, Professor Shintaro Imai. Are you ready?
Yes. Hello. So hello everyone. I'm Shintaro Imai, music chair of CMMR 2021. The music program, which is another important part of CMMRs, was also affected by COVID-19. When we planned to hold the conference on site, we were preparing a live concert at a venue in Tokyo. Unfortunately, however, the music program committee had to decide to change a place for presenting musical works from a real live concert to online video sharing on YouTube. Nonetheless, 32 various musical works from over the world were submitted, and 13 were accepted. We, the committee, selected these works in terms of both of musical and technical aspect, reflecting the conference purpose and theme. At the end of the conference, we award the best musical work at CMMR 2021. The link for the YouTube playlist of the selected musical works is now available at CMMR Slack announcement channel. So I will show you the list. So the playlist looks like this. If you play the list, you can watch the works like a programmed concert. And it's also possible to watch them separately as you like. So please enjoy. Thank you very much.
Okay, thank you. Okay, so this is the end of the opening session, and the next session is the keynote speech by Professor Shuji Hashimoto. We'll start at 16:40. Okay, so we will have a 10 minutes break. Okay, so please wait a little while, 10 minutes. Okay, hello everyone. This is the keynote speech session, and the speaker is the Professor Shuji Hashimoto of Waseda University. Let me introduce you to the Professor Shuji Hashimoto briefly. And he's his major is I'm sorry, I'm a little bit confusing. He was a professor of the Department of Applied Physics in Waseda University for almost 30 years. And he was the vice president of the Waseda University. And his research interests include the artificial intelligence, robotics, cancer information processing, and sound image processing, and meta algorithm. Then some of you may know that he has been one of the leaders of the Gundam Global Challenge project. And since 2014, the Gundam is a very famous anime or robot designed by a Japanese animator. And the Gundam Global Challenge project is also the famous, in which the giant robot make the Leo, which is 18 meters tall, I think, right? So the real giant robot, the project has been building. That's the robot, and he is the one of the leader of the project. And yes, this is a small memory with him. I share right now. That was the 1993. That was the first time of the ICMC conference took place in Asia region. That was the very epoch-making event in computer and music domain, research domain. And Professor Hashimoto was the executive leader, how to say it, executive position of the committees. And he was the virtual leader of the project, really. Since then, I was engaged in the project ICMC 1993 as the how to say, the young computer music researcher. And I have been receiving many inspirations, ideas, knowledge, and experiences in terms of the computer music researches from Professor Shuji Hashimoto since the ICMC 1993. So I'm very glad to welcome the Professor Shuji Hashimoto today as a keynote speech. So I am expecting him to give us many inspirations, ideas, and a perspective to the future of the computer and the music and AI and the robotics. I'm very excited to listen to the Professor Shuji Hashimoto's keynote speech right now. So are you ready, Hashimoto Sensei? Thank you. So start, please start. So.
Okay, thank you very much, Professor Hirata. I'm very honored to be invited to such an interesting conference. And I remind the old memory with you since 1993 ICMC. So today, I'd like to talk what I'm thinking about these days on music in AI era, the same as the conference theme of this year. So, yes, this is the contents of my talk. I'll introduce myself at first, and I'll talk about Kansei information processing. Kansei is a strange word for the foreigners, but this is very important, I think. And next, I'll talk about music and technology and about AI today. And lastly, I'll talk about music AI in AI era. Yeah, just a brief my consideration on this theme and conclusion. At first, I'll talk about my research works. So for about 27 years, I was with Department of Applied Physics, Waseda University, and also with Humanoid Robotics Institute of Waseda University. So I managed my laboratory, Sharab, and so many excellent students had worked with me. And in my lab, I have briefly classified 4 groups. The first one is image processing, the video and vision and information image processing. The people, the student and graduate student did very excellent work on the computer graphics also. And the next group is multimedia processing, including music, the sound processing, audio processing, and advanced human-machine interface for music. And so sometimes we did work on the analysis of music and audio data. The fourth one is, we call it meta-algorithm, the algorithm of algorithm, including the neural network and also the machine learning and stochastic optimization. My doctoral thesis is related to the stochastic process. So this is my home group. And the last one is all these vision and media, sound, and algorithms are combined and fed to the robot. So we have a very good robot group, and we make many different autonomous robots and humanoids. And also the chemical robotics and human interface is main theme of this group. So at first, I'll show you the very historical image where in this slide, we started and enter to the music research field. This is a robot, a very old robot, 1984. This robot can recognize score and play the keyboard with 2, Yes, this one. My former supervisor, late Professor Saddam Hotel, was a key member of the project. So I was included in this project. He and myself were engaged in the musical score recognition and also the vision system robot. The AI is not only the score recognition, but also AI was employed in the finger work planning to play the keyboard with 2 hands and legs. And robot can hear human singing and detect the pitch and some simple word to communicate with human. After this experience, we enter the field of music with computer technology. And this slide, video clip is quite the old and my historical works. The first one is, First one is a system, computer music system that follow the human conductor. As a conducting motion is initially communicate and express a musical expression for human performer. This system made it possible to play in concert with human and computer orchestra. The second is a sort of musical instrument controlled by human movement. In this video, professional composer is using our system for his piece. The third is sound generation from grasping. You can express your emotion by just grasping or squeezing the ball made of soft materials. In this video, the sensor's motion is acquired and data fed to automated composing system to generate the accompaniment. The sound is fed to the sensor and computer composing again for the next tune, making an interactive improvisation. The last one is another music system, embodied sound media, played at the annual conference of Japan Virtual Reality Society. As you see the musical instrument device that transforms muscle movement to sound. And this is very important. The muscles are connected to mind. That means direct expression of the performance intention can be accomplished in this system. So we did many different other topics on music, such as adaptive karaoke system that follow the accompaniment is following the human singing. So we have many different musical works in this 20 years. I think this is very, what shall I say? Sorry. I think these are the very, what I'll say, we challenged a variety of research topics on music and sound technology for past 30 years. But I sometimes feel that it was a very epoch for us. It was good old days before the deep AI era. We have to enter the new challenge of music in AI era from now on. So here, through these activities, we were notified that the changing trend of technological development. In this slide, I'll show you some of my consideration about the new trend of technology development. Firstly, the technology of efficiency was a dominant area in the field of engineering. So we need the faster, higher, larger, or sometimes smaller for industry, for convenient life. So in this field, the result of research are explored in the technical journal and academic conference or something like an industrial show. So this technology can be said that to make human Superman, the beyond human or something like that. So the system are required to do what human cannot do. But these 10 years, the new trend appeared. That is a technology for comfort. So we want to have system that can be operated easier and the system that can make us happier or more joyful or sometimes spiritual for service and for quality of life. Such a system is suitable for museum or concert hall or amusement land, like a gun just introduced by the Professor Hirata. So these systems aim to make human human. And the system asks, do what human can do. What is interesting for me is recent AI can do what human can do, it seems. And the high-tech applications is concerning industry area introducing high-tech, including AI, it has been extended. Since the Industrial Revolution in 18th century, for a long time, the technology was applied for the secondary industries. But the extension has been accelerated in these 50 years because of advancement of computer technology. So the first is the secondary industry. In this stage, the machine and the materials, the relationship is very important. And we already entered to the new stage of the high-tech applications for the primary industries. That is agriculture, fishery, and forestry. So in this stage, the relationship between machine and natural environment is very important. We have to consider not only material, but natural environment. And recently, we are entering tertiary industries, third type industry. That means the service and care and entertainment. In this stage, the relationship between machine and human is very important. And we say that we are entering the post-industrial society where the care and amenity is very important. So in these three stages, what we produced is changing. The first one is a manufactured goods, and recently knowledge. And more recently, we are going to produce the appreciation using amusement or arts and produce amenity of life and comfort. So our target is changing. So why we entered the music? Of course, robot to the musician robot is our initiation, our trigger to enter the music, but we continue the research on music system. Why? Because the music has logical foundations. It's very suitable for computer science and also mathematics. At the same time, music has non-logical aspect. So we can find a new or another way to open a new frontier of technology and AI in music. Some people say that one music rather than thousands of words. Why not music? I'd like to say. So the music is a gateway to Kansei informatics. About Kansei, I'll explain later. So here, I summarize the 3 levels of information processing. The first layer is a physical level. The source of the information is a force, a sound, or light, or temperature. Well, that is physical contents. And this layer, the rule govern the system is physics. So we call this field, for instance, signal processing under the physical law. So in this level, the most important reality is objectivity and causality and explanation. And the next, the second level, that we are now in the second level, I think. I call it logical level. In this level, we treat symbols and figure, equation, and language. So in this level, we are free from physical constraint. The rule is mathematics. The computing and logic and grammar is very important. And reality is explained by objectivity, proof, and consistency. The important is we are free from physical constraint in this stage. And today's talk is related to the third level. The third level we call the Kansei level. In this level, we treat the music, picture, the fine art, and facial expression and gesture. In this stage, exactly speaking, we don't have a rule. Just like an emotion on the ambiguity is the very dominant. And human factor and affordance is one of the very important or governing rule in this stage. The reality is quite different from upper two. That means the subjectivity. And we cannot measure the reality as a physical phenomenon or the mathematical consistency. We have to measure this as an appreciation level, or something like resonance in mind. So the difference can be found in the communication manner for machine. About the command to machines, the touch and pressure is a physics. touch the button or press the button and make off the switch, something like that. We need a force to give a command in this level. After such the on-off level, in the industry, they're using another level of command. It's a logic that have a meaning. There's something like walk or stop. And also, in the automation system, we need another type of command that is numeric to give a volume to the system. For instance, advance by 1 meter, but rotate by 45 degrees, or something like that. And about more than 10 years in Japan, we are entering the new field, another field of the command to machine. That is a fuzzy command to express the degree of the motion or the function. For instance, walk a little bit faster or speak more slowly, something like that. The computer is now very powerful. So this command can be converted to the numeric command in computer using something like a dictionary, the accumulation of the data, something. It's very not difficult. Now we can use such a command. And the last level is the next future type. I call it Kansei level. In this level, we ask the machine about the quality, something like, for instance, the dance elegantly or play emotionally or something like that. So this advancement of the communication manner is going on right now. So this is the change from objective to subjective. And advanced interface for human-centric system, the system must understand users' Kansei. The computer has had enough power to understand human intention without words. And data are increasing globally everywhere. So we call it big data era and AI era with deep learning, deep machine learning. So as I use the term Kansei, what is Kansei? The most Japanese people can understand, but cannot maybe define. But for the foreign people, it is quite difficult to understand, maybe. So I'll explain a little bit. Sometimes in Japan, we said that the post-industrial society will be the Kansei society. So Kansei means sensibility, emotion, sense, feeling, expressive spirituality, affectiveness, or something like that. All are included in Kansei. So sometimes it means subjectivity, multivocality, ambiguity, something. Then the Kansei is emotion, or Kansei is intuitiveness, or Kansei is affectiveness. All are included in some sense in the term Kansei in Japanese. So also Kansei is sensitiveness. So I would say that Kansei is another human ability of understanding. This is quite different from logical understanding. what is based by recent AI. I'll show you the usage of kansei here. In Japan, we use such a sentence very often. This is kanji character, Chinese kanji character, meaning kansei. But the Chinese people, the meaning of kansei is a little bit quite different from Japanese. So the kansei is something like a Japan original, what's right? So usage, the ha kansei is excellent. You use this sentence very often. And next one, he's a man of deep kansei. The similar meaning. And this is opposite. He has no kansei. Her kansei seems well suited to me. This is also very often used to criticize the artistic work or songs, singing. The Beatles express the kansei of late 60s. This is also very often we use in many different situations. This tune stimulates my kansei. It's also we use. Then polish up your kansei to be an artist. My kansei cannot accept this music. Maybe even if you are not Japanese, that maybe you can understand what the kansei include, the very wide sense of the sensibility or affectiveness or something like that. And also, I'd like to introduce another word, kokoro. The machine with heart, that means the machine with mind. The mind or heart is in Japanese, kokoro, machine with kokoro. Sometimes in the field of human robotics, I gave a talk about how to make a machine with a heart or something like that. And kokoro is not just a concept, but something like the organ. The kokoro is an imaginary organ governing kansei functionality. We Japanese believe that it exists in our chest, not in our head. So this may be the same equal to the foreign people, that because in English, we say that the heart-warming the story, then the warm-up is not a brain, but something like a heart. The heart, if you see a tragedy, then you feel pain in your heart, in your chest, in your kokoro. So I would say the machine needs kokoro to understand kansei. The road to technology for amenity needs kansei or kokoro functionality. The kansei functionality cannot be described with a compact rule set, but it is essentially related to big data issue and AI, especially the future AI. Here, I'll introduce a kansei research in Japan. Many people in each country, the government had a grant for the scientific research. And the granting aid for scientific research is the most biggest grant by government in Japan. Sorry, this is. So the largest grant in Japan for science research. And there are so many different class of grant. And one of them is granting aid for science research on priority area. So in this area, the main people in the information processing applied a new priority area proposal. That is Kansei information processing in visual and auditory media in 1992. This is a 5-year project, a 4-year project, and get big money at that time. And I was included as one of the researchers in this project. At that time, we talked about how to translate Kansei in English to English. Very long time discussions. As Kansei meaning is widely spread, but we Japanese can understand what is Kansei. So I can feel. So it is quite difficult to translate to the foreign language. So we decided to use Kansei itself as a term, technical term, even in the paper written in English. And after that, the Kansei word became very popular in research area. And now, in the granting aid for scientific research of Monkasho is a Ministry of Education and Science Research grant category has many different categories from the science, engineering, the literature, sociology, and medical, the many different areas. And they're classifying the areas. The medium-sized section, 61, is a human informatics and related field. And in here, the Kansei informatics, this word is included in this, the core of the granting aid right now. So the Kansei informatics or human informatics field is very popular in Japan at present. That would include the Kansei design, Kansei cognitive science, Kansei psychology, Kansei robotics, and blah, blah, blah. So many. So about the technology for music, I want to say that it should include physics and logic and also Kansei, and have a tendency of universality and individuality. And objectivity and also subjectivity must be considered. And another important thing is we have to consider about the human and environment and the context. And also, I'd say the more important or very important issue is evaluation. That means the human intention. And sometimes real-time nature is important in the technology of Kansei. And this is very rough classification of the music-related human activities. The first one, the composition, to express the intention or some thought, thinking to the music or sound sequence. And next one is, of course, the performance. And the appreciation by the audience is very important. To realize such activity, we need the device to generate sound. We call it some musical instrument. In this instrument, the production is important, and performance technique is also required, quite different from instrument to instrument. And another music-related human activity is related to the science, that is analysis, the grammar, something like linguistics, and description way or manner or rule, and also the perception, psychological perception or something. Cognitive science is very related to in this area, and also interpretation, and more physical level, sound processing and analysis is very important. And recently, we have to treat the very big data of music for the classification and discovery something. So these activities are related to each are related to the technology. This is the one example that composition is related to human, which is assisted by machine in sometimes. And the performance in human and machine, the cooperative work is very important. But only one thing, the appreciation is human at present. Other instruments is, of course, a human with machine tools designed by human and assisted by machine. It's each stage of production and performance technique is quite difficult, quite important. And for science analysis, the human with machine analyzer is now the user. For instance, for grammar, linguistic data analysis, machine reading, psychophysiological analysis, and semantic analysis, pattern recognition, and big data analysis is introduced, employed technology in this scientific field activity. So about the evaluation issue, this is also very important and related to the, what shall I say, the quite difficult comparing to other level of information processing. That is that I'd say that usually the physical level, something like signal processing, the accuracy is very important. That can be measured. And for the logical level, second level, that maybe the artificial intelligence these days is included in this level. The correctness is important, not accuracy, but correctness. That is measurable by the cognition rate of something like that. This is not a physical measurement. In cancer level, the artistic technology is included here. I cannot say exactly what is important. This is one example, that fitness. That means the appreciation degree must be employed for the evaluation of the system. So again, this three level is different. The first level, objective to subjective, the down. So many years ago, I wrote a paper about the evaluation issue of such cancer systems. And I said that scalar evaluation is a conventional evaluation, the single criterion. And vector evaluation is another or improved one. So not a single, but some, what is that? factors are considered at the same time. But this is not enough. I would say the multi-phased criteria should be introduced in Kansei system or artistic system to introduce the diverse perspectives. So at here, I'd like to talk about the, what shall I say, this one, personal experience about this evaluation issues. I wrote this story in the Journal of New Music Research 10 years ago, that this is my experience. When we developed a computer music system that followed human conductor, we evaluate the system from the plural viewpoint. So this is, I think now I consider that this is just a vector evaluation. The accuracy of button positioning detection, and also the tempo prediction, and also rate of the conductor's gesture was measured, commission rate. So this is not enough, I consider right now. After that, it's more than 10 years more. We submitted a full paper to Japanese, in Japanese, on the automated accompaniment system for singing to the Journal of Information Processing Society of Japan, JSPS. And as an experimental result, we described the relationship between the singing tempo detected by speech analysis and accompaniment tempo with the score positioning of singing. Then one of the reviewers asked us to show the real singing tempo in the experiment. This question is quite proper to evaluate the accuracy of the tempo detection. However, no one can know the real singing tempo. Even the singer cannot tell his exact tempo of singing. What he can do is to tell the tempo in which he tried to sing. Therefore, we added the data of singers' finger tapping during the singing. Maybe the reviewer knew the problem well because the revised paper was accepted soon. The most essential problem does not appear in above story. When we should evaluate the adequacy of the accompaniment. How? No, who should evaluate the adequacy of the accompaniment? We have another story on the adaptive accompaniment system. After the development, we tested the system by asking a professional educated singer. His evaluation was good to satisfy us. Some months later, the system was used by amateur young girl for TV program. She told us that she preferred the ordinary karaoke system, even if the new system can adaptively follow the singer, because she wanted to sing at the original tempo as just as a famous singer. So the evaluation is quite complicated. And finally, of the story, I'll give a different example to show that universality is not always required in art. About 20 years ago, Mari Kimura in New York, is a violinist, introduced a new bowing technique named subharmonics to extend the violin's range by a full octave below the open G string without changing the tuning. At present, and he composed some piece using this technique. At present, even now, this technique can be handled only by Mari Kimura. However, some composers has written pieces, including subharmonics. In science, if the technique which can be realized only by a specific person and its mechanism is not clearly stated, it is almost of no value. It is true that the individuality often seems more important than the universality in artistic field. Yes. So this is my personal experience about the evaluation of the new level of the system or technology. So next, I'll talk about the AI, the full-scale AI that has come earlier than expected, at least for me. Why I said than expected? I believe that science does not fully elucidate human intelligence. We cannot understand fully the human intelligence mechanism or the functionality. So the many people say that novel technology is said to be created by engineering based on science. But presently, the deep learning-based AI produces solutions directly from the huge accumulation of raw data. It seems that the science is blown off from the traditional picture of technology. The rest is engineering alone that delivers good solution. But it is natural when we see the history of humankind. The technology without science has been leading humankind and civilization for a long time. So I would say the 20th century was a happy era for science, as science almost managed to bring technology under control. So that this 21st century is what's changing. So, and also the one of the exceptions is the field of music. In the field of music, not science, but technology led the field for a long time through 20th century. I feel. Now, I talk about issues on the recent AI, the problems. At present, AI works well, almost, but not all, but almost well. However, it does not tell us why the answer is correct. There is no proof of validity. Of course, we have some field of AI, we call it explainable AI, but this only visualizes what are happening in the system. That means network. The output AI sounds like a God revelation. The similar situation is observed when we ask the Meister at the violin workshop or craftsman. What we can do is only to believe in AI and him, because we believe they know everything. They experience so many. With the recent days of AI, this is cynical, in my view, that traditional decent researchers who accumulate appropriate process based on theory and knowledge to approach the solution seem to have been exiled from the main stage in many fields of science, including music. That is cynical view of myself. So, but I'm not pessimistic about the current situation. We need a science to understand things. And most importantly, I want to know. The science hates black box, while engineering often accepts black box if it is useful. Useful tools accelerate science. AI is not yet in the final stage. Neither human intelligence is not. I believe we need to start a new story of science together with a new tool, that is AI, as what cannot be realized must be narrated. This is the word of Umberto Eco, an Italian philosopher. The music is a fascinating field in elucidating true human intelligence and creativity, as it contains philosophy and arts, science and engineering, and logical and concept aspect of human. So this is the same slide I previously showed. In the music-related human activities, the what present AI can cover. This is roughly, I consider that this area, instrument making and analysis, AI at work can assist greatly. We have very good tools from AI. But for the future AI, I expect to understand composition, performance, and appreciation, and sometimes instruments. The future not developed now, but future AI should cover this area. And to do this, we need a research of music and technology. That means now we have a strong weapon, AI, but not the final weapon. This is. The music has been advanced along with technology development, while the science of music has been following music, but not lead. So this is my personal observation. Maybe no, or maybe not true. Looking at the history of music, music seems to have a potential to lead technology. Useful tools accelerate science to know that even if in the field of music, AI is not yet the final stage, neither than human intelligence is not, as I said. So I believe we need to start a new story. That is, again, I'd like to say again this one, with a new tool, AI. The music is a fascinating field in elucidating the true human intelligence and creativity. Yes, again, I'd like to say, as it contains philosophy and art, science and engineering, and also logical and concept aspect of human. So I said the twice, what I think that is important, they're important. The music was born most early in the history of mankind. Technology had developed music, and music has also promoted technology. This is true. So today's AI against the backdrop of large amount of data is, after all, just interpretation. extrapolation is not possible. The extrapolation requires true knowledge that related to science. Science has never created music and has always followed it, as I said. But in the age of AI technology, music can have a good relationship with AI. And in particular, we can expect scientific elucidation of concept through music and AI. However, the current way is not enough. And in order to open up the possibility, it is important that music promotes the development of AI so that it will lead to a true elucidation of intelligence. Music has the power to tell. Again, I'd like to say, that's a misprint. If we cannot tell a story again. So the concluding remarks, today's AI is a statistical method based on a large amount of data. Therefore, the averaging operation is at its essence. In other words, it results in leveling the derivatives, the difference. Creative music that appeals to conscious seeks difference in many senses. Music in AI era has a potential to improve AI to shape another one that think different and that makes, accepts, and respects differences. I do not intend to make artificial intelligence human, but I hope to know what is human intelligence through music in AI era. So that's all. Thank you very much. Thank you.
Thank you so much, Professor Shuji Hashimoto. Okay. Any questions? Any questions? No? Okay. So let me give some questions. You say in the last part, within the framework of the inductive learning, given the big data, the AI, in particular the deep learning, does the interpolation calculation, computation, rather than the extrapolation. That is the, yes, I agree with you to some extent. And this is the, this is the, is this the useful for to explore the secret of music? So
yeah, I say that the present AI, based on the big data, is just an interpolation. So, but to know what to explore the out of data area, we need extrapolation. So that means we should know the scientific theory or the mechanism knowledge of the phenomena, not the data. Even if the data is very dense, then we don't know about the outside of the data area. So this is a very serious problem for the recent AI. So I say.
The other than music, for instance, the visual recognition or sound recognition, the deep learning, it seems to work well in terms of the interpolating calculation. And because I think it is because the structure, the deep learning or the system supposes are have the good correspondence between the mathematical model and the physical models. And so that is that is the reason why the deep learning can work well in terms of the vision or sound field. And so if we can have a good mathematical model of music, we could make a good interpretation of, for instance, two melodies and two chord progressions. So I think interpretation is a kind of a good test, or how to say, the good a good signal, a good mark for checking the mathematical model can work well. So to summarize my question, the not only extrapolation but also interpolation is important to exploring the inside or the internal structure of music.
Yes, I agree that of course I don't say that the interpolation is not useful.
Okay.
Of course it is useful, but the limitation exists. That the interpolation method can describe only in the space of data distribution, distributed area. But sometimes for physics or other science, they don't use the data. Then they have some assumption or something like that to extend the role of the data space beyond the data distributed space or dense space. So the one possibility is to make a theory or the formula, something like that, using the given data. That is the fit to the limited area where the data exists. But this formula is true out in the outer space. I'm very curious about that. So because the deep learning or other systems right now we have can fit only the data. They don't use something like the governing law of the data space. So, but science itself, it's essentially have to discover the log of the data distribution behind. But in my view, that the present AI cannot do that. So we have some complaint about why this solution is good. Of course, the almost solution is good, but we have to believe, not understand the output of the AI system. So what I want to say is, it is okay, but in the music system or the music, maybe music can stimulate the AI researchers to go outside of the data space. This is my personal comparison.
Oh, good suggestions to the people of AI field, I think. Okay, so the time is almost up. And so I would like to conclude this session, but post-session discussion will take place in the Zoom breakout room. Maybe in the Slack, you can see the two Keynote Hashimoto room is there. So that if you have some questions and comments or some other business, so please go to the Zoom breakout room to Keynote Hashimoto. You can see that keynote speech room. Okay. So again, we would like to thank for the Professor Hashimoto's keynote speech by big hands. Thanks so much.
Thank you very much.
And what is the next? What is the next? The program. The sponsor session will start at 6:10, 18:10. And okay, so they're almost 70 minutes later. And if you want to break, please take a break. And if you want to talk with the Professor Hashimoto, please go to the Zoom. And the other person, please wait for the next session, sponsor session. Okay. So Professor Hashimoto, please go to the breakout room. Can you go there?
That means the number 2 keynote Hashimoto is correct?
Wrong.
Wrong?
Wrong. The name of the breakout room is keynote speech.
Keynote speech.
Can you see the breakout room list?
But where? In the Zoom?
At the bottom line, and many icons you will see, and among them the breakout room with the icon. How to say?
Okay, I see.
The tambo in Chinese character.
Okay.
So please press the button, and you will see. Okay, you can go to the keynote speech breakout room. Okay. See you later soon.
Hi, so I'll be presenting at the next sponsor session. So if you would please, I'd like to do a quick mic and sound check. So I'll be sharing my PowerPoint. And could someone in the CMMR staff check if you can listen to the audio? And let's see. Okay, cool. Can you see the screen? Okay, now I think I'll be playing back a movie. So if you can see the movie, please let me know. Okay, so that's it for my mic check. Thank you.
Hello, Maizawa-san.
Oh, hello.
Noise. Have you checked the audio and video? Have you checked the video and audio of Zoom?
Yes, I've checked the microphone and the video. Yes, I think.
You have 50 minutes for presentation of sponsorship. So please make a full use of the 50 minutes for the sales promotion and benefits or increase the stock prices and
Yeah,
ready?
so yes, you're ready. Very noisy.
By your microphone.
Yeah, so I think it's the fan noise. See if there's something we can do about this. So maybe I will do some noise reduction. How about this?
Zero noise.
Okay. So
Okay.
maybe
It
I'll
works.
go with this.
Okay, go ahead, Maizawa-san.
Okay, so let me share my screen. So actually my talk will be maybe something on the order of like 20 or so minutes, but we can use the additional time to have a discussion in a breakout room for those of you interested. Let's see. 1 second. I think now I'm covering some parts of the screen over here. Okay, so I'd like to use this time to kind of introduce some of the research at YAMAHA that's related to computer music. This is, so I'd like to introduce some of the works that our team does. So first of all, who are we? So we basically make musical instruments and everything related to music production. So anything involved in making music. So we produce anything from acoustic instruments, like guitars, wind instruments, percussions, digital keyboards, guitars, basses, amps, and so on and so forth. We also have work in like audio regime, like pro audio mixers, and commercial audio solutions, like of these things used for teleconferencing. We also have like audio-visual equipment for your, for example, like your TV and like DVD players and stuff like that. And we also work on like music production, so software like Vocaloid, and we also Steinberg as part of our subsidiaries. So basically, we have like software, hardware for music production and making some noise. Yep. So I just want to mention that YAMAHA's research is also likewise very interdisciplinary. We have lots of we have a wide product portfolio. Therefore, we have like researchers and like music instrument acoustics or electronics, like music psychology, perception, and information retrieval, which is what we are working on. And we also have like facilities like recording studio, professional grade recording studio, various or anechoic chambers. If you can see the mouse cursor, like the one on the bottom right is basically like a very small, essentially like a small concert venue, which we can use to do like test our PA equipments or have some like jamming fun once in a while. And we actually have like a couple good pianos in actually good tuning conditions, which is very nice for me. Yeah. So today, I'd like to kind of keep this short and talk about MIR research from two topics, one based on content analyses and another related to performance, and kind of show kind of under the hood of the kind of technologies that we use. So for content analyses, for example, we have two apps in the market. One is called Chord Tracker, which allows you to basically analyze a musical audio signal and bam, extract chord progressions, beats, and guitar tablatures on the fly. So basically, you can transcribe chord progressions and transcribe it to task. Also, there's like a functionality to simplify these extracted chords so that the beginning guitarists can play it in a limited number of forms and still sound fun, and decent. Also, Smart Pianist is basically like a spin-off based on it for keyboards. So this is basically you analyze musical audio signals and you get this backing track with the proper chords and that you can play. Also, what's kind of nice is it will drive illuminated keys, which is from our CSP product lines. So basically, you'll have like a LED on top of the keyboards, which will show which notes to play, so that even if you can't read this music score, you can still actually play the chords and have the audio play back along with what you're playing, so that you can still the users who cannot read the music scores can still play along with the audio. So I'm just going to show you a quick demo of myself performing Chord Tracker from the song that is very, very well known in this community called the RWC MTV teaser. So you can kind of see that the chords are in sync with the music playback. You can kind of see different structural boundaries being colored differently. So we have all of these music IR research outputs being used on very good. To kind of share you some of the things that we do to achieve this, I'm going to talk about some technologies that we use. One is about rhythm retrieval. So this is the task of identifying what will be a good rhythm pattern to play along the musical audio. And because we have lots of automatic accompaniment assets, we formulate this as a retrieval task from one of our commercial grade rhythm pattern databases. So basically, we do like a feature extraction of rhythm and spectrum and try to retrieve the best rhythm pattern based on rhythmic similarity, and the similarity of the timbres can basically contain in the rhythm patterns along with their respective rhythm patterns. Okay. Or for example, if we want to extract the chords, what we do is we extract from chroma-like extraction and jointly estimate the key and the chords. The idea over here is basically what's kind of interesting is that because we have been releasing a Chord Tracker for quite some time, like I think 5 or so years, we have lots of annotation records from our users from our old versions. And basically, as we improve our versions, we use these baseline chord recognizer and train a model of how the user fixes these chords to improve our chord recognition. Now we want to talk about music structure. So this is like trying to feed an audio signal and trying to segment it into similar structural units like verse and the chorus. And what we do is basically extract segmentation by searching for segmentation that matches 3 measures of thickness. And so basically we are going to look at like the durations of each segment to see if that corresponds to a good segmentation. We also look at the consistency of timbre within a measure. and also to see how the structural boundary explain how much the proposed boundary explains the acoustic signals. And we are going to combine both these to find desegmentation score. So, like we are going to use like kind of modern techniques like deep learning techniques, and use some of the insights that the music information retrieval community has acquired over the years. Then in the chord tracker, we have we extracted beats so that you can display the chords in sync musically with the audio signal. So what we're going to do is basically a very classic way of estimation where we extract onset tempo features and spectral features to jointly estimate the tempo curve beats and the bar lines. But actually, recently we are kind of starting in a new direction in that the beat detection is something which, and many other music IR tasks do not correct answer, but rather the correct answer depends on the user's preference. So basically, what we do is to not only train a beat tracking model, but allow a more flexible way of correcting the beat tracking results and feeding back to the machine learning model. So basically, we are kind of employing this human in the loop kind of approach where humans involve themselves in the machine learning process so that I can better to each user. Okay. Also, in terms of contents, we all deal not only with music audio signals, but also music score data. This is lesser well-known fact in overseas, but actually we do have like a music publishing company, and so we have some so for example, in this example, what we have is we are trying to have this piano roll-like representation on the top and trying to cover the clefs, time signature, the stems, voicings, and these things that makes music score readable. So basically piano roll to music score conversion. And for this, we use transformers, a very quite recent machine learning model that has shown lots of promise in natural language processing to feed lots of music score and try to learn the correspondence between the piano roll and transform it back to the music score. Additionally, because we also employ the transformer to add fingering markings, for example, on the piano score. So basically, we train a transformer to estimate the fingering based on the trained pairs of fingered and non-fingering music scores. So those are like some of the content-based research that we do. Additional area of research that we do are those related to music performance, because we'd like to create, for example, engaging music performance experience for our users. So we want to so we are trying to find new ways of expressing music through different ways of performing, or to use performance as a way to derive musical systems. So over here in the example, I play the violin, feed an audio signal of the violin, and a system will play back piano accompaniment from music score with a human-like piano touch and velocities added. So that's like a kind of an application of score following and performance rendering, both of topics were both of which are active research areas in music IR. Also, we apply this to train music performance rendering from audio recordings. So in this example, what we did was to train Glenn Gould's recordings and train music performance rendering engine based on the analyzed recordings of Glenn Gould to create piano accompaniment system that can play in style of Glenn Gould. And we did a trio concert based on that. Yeah. Also, for example, we have this installation which allows a beginning pianist to have their interactive virtual accompanist that can play along with the user. The idea over here is to be able to analyze the articulations and the velocity and the touch of the pianist to dynamically change the accompaniment to match the user.
で U の場合は人間が演奏する速さを変えたりですとか演奏の仕方を変えたりするとそれを瞬時に察知して伴奏をリアルタイムで変えてくれるというところが大きなポイントです。
機械と触れ合ってるんじゃなくてあくまでも人と楽器が向き合ってる中に誰かが寄り添ってそういったものを後押ししてくれるっていう人のポテンシャルを最大化するための人と楽器をつなぐパートナー AI が主役になるんじゃなくてあくまでも人が主役。
I can see it working.
So like some of the things we work under the hood, we are working on score following technologies or performance generation technologies. One thing that we are doing is to use multimodality for score following. So basically, in typical score following, you would use only auditory cues, but that's usually insufficient to extract like gesture, like cue motions, for example. So what we did was to combine computer vision into score following to, for example, detect motions of like the violin's neck, or recently the deep learning based facial recognition landmark recognition is improving. So we are using like landmark tracking to analyze gesture-like motion. So you can also not only recognize, but also generate pianist-like motions. So for here, what we were doing is to feed a piano roll of piano's performance and trying to estimate the joint positions of the piano performer. So I think there's like going to be if I recall, there's like a very interesting presentation on Thursday related to generating the double basis motions. I'm looking very forward to hearing that. Anyways, so the idea over here is that if you want to create piano motion, a nice approach would be to use like inverse kinematics to constrain the hand position and generate the motion based on the inverse kinematics. But the problem is that motion is also very expressive. It has musical background and musical ideas embedded. So for example, one might kind of lean forward and phrase crossing boundaries. And these kind of things you can't really express using kinematics alone. So we used deep learning to try to map to see if you can uncover these kind of musical intents from piano roll and reflect that to joint positions. So actually kind of relating back to the previous keynote, I think what's kind of interesting is that, but you can't, with these kind of things, you can interpolate bits and pieces of information present in the piano roll to actually recover some interesting gestural information. And likewise applies for performance rendering. So as you know, piano performance rendering is the task of converting music score, feeding a music score and generating a realistic piano performance with the good human-like velocity, timing, duration, and tempo. And over here, what we did was to start off to learn the mapping from not only piano score to the piano performance, but also to try to uncover the latent space of possible expressions. So what I mean by this is that in a music score, you can play music score in very different emotions, different expressions. And if you try to train a one-to-one mapping from music score to piano performance, you lose all these subtleties and variations of performance. So what we did was to embed this into a latent space of performance from which we can kind of like sample the trajectory of expression, if you sort of will, and combine this trajectory of performance along with music score to create piano performance whose expression changes dynamically over time. So again, I'm going to show like this time, only the music performance result based on data set that's being automatically analyzed from Glenn Gould's recordings. And I'm going to perform a piece that Glenn Gould has never recorded in his lifetime by Johannes Fischer. So this is, you can kind of note that, for example, like the inner voice tends to be very emphasized and the articulation tends to be more short, which is kind of typical of Glenn Gould's playing nuance. So in some ways, you can kind of see that there's like the trace of Glenn Gould's left in the trained model. Another interesting example is the Gould variations, which is the piece which unarguably is Glenn Gould's most famous performance. He has recorded 2 different renditions in and what we did was to train our model on Glenn Gould, except we didn't include any of the Goldbergs. So basically, this is kind of like trying to recreate Goldberg by listening to all of the pieces that Glenn Gould has performed in his lifetime, except for the Goldberg, and see what comes out. And so on. So you can also kind of hear, I personally kind of heard traces of like his English suites or some of his symphonias. But so it's kind of interesting because this is completely unlike how he played the Goldberg, except there's still kind of traces of Glenn Gould left, some traces that you can kind of hear. Also, we are working with combining with other modes of expression. So, for example, in this example, we apply score following to have a system that listens to the orchestra and tries to synchronize a video clip in real time with the orchestral performance. So if you can imagine like Disney's Fantasia, this is basically a system that tries to do that for a live orchestral performance. So this is, we use score following and kind of like a good, clever human intervention mechanisms to enable video playback that works in these kind of live performance. And what's kind of good about this is that originally when we want to do this kind of things, we needed like a stage operator that's both that's expert in both the musical content and the video content. But I'm trying to train this kind of operator, the manipulator that specializes in 2 areas that are very difficult. So basically, by using this system, we are able to kind of offload some of the burdens of trying to learn the audio material, so that the video operators would be able to just concentrate on the video material. Additional thing that we did, for example, is to expand the possibility of performance by using dance as motion input. So over here, what we did was to acquire muscle, electrical activities to use that as to drive this clavier player piano. So in the next clip, you'll see a dance movement triggering a piano. And so I forgot to mention, so this animation was also a joint work with Tokyo University of Arts, and so is this one. And over here, we will have this performance of the dancer Kaji Moriyama dance and drive this clavier player piano, and have it accompanied by the members of the Sharon Ensemble of the Berlin Philharmonic. And so on and so forth. So to kind of, I'd like to, if you're interested in discussing more, I'll be happy to discuss it either in the Slack or probably in the Zoom. Also, we are offering one internship topic, music performance motion analysis research. So basically, this is trying to use motion to, for example, different sensing mechanisms to be able to detect, for example, music conducting motion or some gestural information that music instrument players give on stage. So if you are interested in this topic, which is open for next summer, please drop a message in Slack to Takuya Fujishima. Also, we'll have more research openings in areas that I've introduced previously and more around March 22. So you can check out the webpage over here. I'll post the QR code right after for if you're interested in working in this kind of area. Okay, thank you very much.
Okay. Thank you for presentation. Any questions? If you have anything, not only what he has just said, but also products. Oh, please now, Aoki-san. Now, Aoki-san, do you raise your hand? No. Okay, we have much time to to take some questions and for you to make more presentations. Do you have any materials or slides or sounds, videos? Maezawa-san.
Let's see. I think this is pretty much the of the English content I have. So, I mean, so if you, I mean, I wouldn't mind, finishing it off for a nice evening, early evening or afternoon or morning or wherever time zone you're in, you are in. And if you have additional questions that pops up into your mind, you can please feel free to drop us a message in the Slack sponsor. I think the sponsor Slack channel, and we'll be very happy to discuss.
Okay. So do you have something about the internship for students or the announcement to the worldwide audience of CMMR 2021?
Yes. So as I mentioned, so in the QR code over here, we have a link to our internship openings page. Unfortunately, it's still closed. It'll be open in March of 2022. And also, so again, we are having our intern topic on music performance motion analyses. So if you're interested in movements, motions for musicians, and have some background in machine learning, and are interested in this kind of field, please drop us a message. This you can apply by sending a message to Takuya. So, yep. Please feel free to apply.
Okay. Okay. Do we conclude the session? Can we? And
Sorry, I have a question.
okay.
Hello, thank you very much for interesting speech.
Okay, Sylvie, go ahead.
Yeah, I was just wondering concerning your performance motion analysis, what kind of research topics you're interested in, and if you're interested in several kinds of research topics in this area, or what precisely you're working on.
Yes. So basically, we are right now interested in applying motion recognition to basically enhance our music performance systems. There are two directions that we are interested in. We are open and kind of refining our the intern research topic based on these two, and one being music conducting. So we have some music conducting system that's available in Japan, where you can enjoy like conducting virtual orchestras. We want to enrich this experience through use of music performance analyses. So, for example, getting musical gesturized triggers to be able to better control the systems. So, if one topic is in better recognition of music conducting gestures, another topic is to be able to recognize musical gestures better. So, for example, nodding gestures of, for example, pianists when giving a cue, or kind of like different nodding motions that people would give to indicate the tempo, and these other kinds of explicit and implicit modes of communications for musicians. We want to be able to recognize these to, for example, combine with our like this kind of music ensemble systems. I hope that was a clear enough answer for you.
Yes, thank you very much.
Okay, thank you.
Okay, let me wrap up the session. Thank you so much, Maezawa-san, for your talk.
Thank you.
And if you have questions or comments to the Maezawa-san's talk, please go to the Slack channel named 5 Sponsor Yamaha. And maybe Maezawa-san will watch the channel every time. So the audience, you will be able to have a quick response from Maezawa-san, hopefully. So thank you so much again. So please have a big hands to Maezawa-san. Thank you so much.
Okay, thank you.
So this is the end of the contents of the day. I would like to close today's CMMR 2021. know the why, but I was forced to go to a breakout room. I don't know the reason. Anyway, thank you so much for your attention to the CMMR 2021 of the day. See you tomorrow. Is it okay?北原先生。
あれおかしいな。
北原先生。May we conclude?
入んないな。
See you tomorrow, everyone.
平田先生。これ何ですか？